In this video, we'll be looking at angles created by lines. Straight lines create an angle with the positive x-axis. So in this diagram here, you can see that we've got a blue line with a positive gradient that's creating an acute angle, which is an angle between 0 and 90 degrees, with the x-axis. So if we have a look at that, we can create this right-angled triangle where the opposite, okay, so this is the opposite side of our angle, is the rise, and the adjacent side is the run. So we know that tan theta is equal to opposite over adjacent, which means it's equal to the rise over the run, and rise over run is in fact the gradient or m of a line. So we find that tan theta is equal to the gradient of a line. Therefore, we can determine what the angle is by using the inverse tan function. So we find that theta is equal to tan inverse of the gradient m. If the gradient is positive, the angle will be acute. So we can see that situation down here. We've got an acute angle created with the x-axis. But if the gradient is negative, the angle is obtuse. So that means that it is an angle greater than 90, but less than 180 degrees. So it's really important that if you're calculating the angle for a line with a negative gradient, you will first calculate an acute angle. The acute angle that you find will be this angle here, and we might label that alpha. And if you want to find the theta angle, the angle created with the positive x-axis, you need to subtract the value of alpha, or this acute angle here, away from 180 degrees, because we know that a straight line has 180 degrees in it. So next we'll look at a couple of examples of finding angles. So for each of the following, we want to determine the angle marked theta, and we want to state our answer correct to 1 decimal place. So we know to find the angle, we need to know the gradient of the line. So for both of these, we're just going to look at the rise and the run. So for the graph in part A, we run from 1 to 3, which is a run of 2, and we rise from 0 to 3, which is a rise of 3. So we can say that our gradient is equal to the rise, which is 3 over the run of 2. And next we can use the formula theta is equal to tan inverse of the gradient to determine the angle that line creates with the positive x-axis. So substituting in what we know, we can say that theta is equal to tan inverse of 3 divided by 2. And if you put that in a calculator, you find that that is 56.3 degrees, correct to 1 decimal place. For part B, if we run from negative 3 to 4 horizontally, or in the direction of the x-axis, we can see that we go 7 units in this direction. And instead of rising this time, we fall. So we fall 2 units, so I'll put that in as negative 2. So our gradient for this graph is going to be negative 2, the fall, over 7, which was our run. So because we have a negative gradient, we're actually going to find the angle in here, which we'll call alpha, when we do our calculation. So we're going to say that alpha is equal to tan inverse of the gradient negative 2 divided by 7. And if you put that in a calculator, you find that that is equal to negative 15.945 degrees. So that angle there, it's just said it's actually that angle, but they are vertically opposite, so they're the same angle. And now if we want to find what theta is equal to, we need to say theta is equal to 180 degrees minus that 15.945. Therefore, we find that theta is equal to 164.1 degrees, correct to 1 decimal place. After this video, you should be able to calculate the angle a line makes with the positive x-axis,